Hello, today we're going to talk about comparison test. So for the comparison test, we have the series of A of k and the series of V of k is the positive terms as AK is bigger than 0 but smaller than BK. So that if BK is converged, then AK is converged. If AK is diverged, then BK is diverged. This can understand as the series, like the two functions like this, B of k, A of k, 0 right here. So this one down is if this one is converged, then this one is converged. However, if attached right here, if this one is diverged, then the functions B of k is diverged. Also, comparison test. It is just a rule that you have to apply another series test for it. So comparison test, you have to use, by that you have to use two series test at first place. Have to use comparison test to find BK to conclude the series is converged, and find AK to find the series is diverged, and then used another series test to check for AK or BK is diverged or converged. The example for comparison test is just a squared plus 10, for example. So right now, k equal with 1 and infinity. So I compare the series with the series of k squared. So at first, I'm gonna find the highest exponent for the main point. So you can see right here, k squared plus 10. So k squared is the highest exponent. However, if you have a series of k to the third plus k squared plus 10, for example, this one is the highest exponent, so the series gonna be k to the third that you can compare with. So right now, let's do this equation for example. So I know the series of k squared, k equal 1 infinity, limit of k to infinity of k squared is diverged, since it is equal with infinity, different than 0, divergent test, and k squared is smaller than k squared plus 10, so that the series of k square is diverged. So the series of k square plus 10 is diverged based on comparison test. Another example is that k to the third over 2k4 plus 10. So I'm gonna compare this one with the series of k to the third over 2k to the fourth. Is the series equal with 1 over 2k, which is diverged based on harmonic series. Or you can use p series, which is p is smaller or equal to 1 at the series is diverged. And then we have to prove this series has to be bigger than this series. What is the relationship between the series given and the series that we create? By that, we know 2k to the 4 and 2k to the 4. It equal each other's, but then this one times 10, so then it's gonna change the signs. However, we divide both sides by k to the third, then it's gonna once again it's gonna change the size. Since, like, for example, that you have 1 over 1 and 1 over 1 plus 10, this one will be higher than this part, right? Where the denominator is higher than the whole number is smaller. And then we know this one is diverged. By that, we cannot conclude this series diverge. That is why we have to move to limit and comparison test. We are going to limit comparison test. Let series of a of k and series of b of k positive, and limit of k to infinity of a of k over b of k equal L. So condition number 1, if 0 is smaller than L and smaller than infinity, then both series converge or diverge. Which is at L is just any constant but different than 0, higher than 0. For number 2, if L equals 0, then the series of b of k is converged. Then the series of a of k converge. Number 3, if L equal with infinity and series of b of k is diverged, then series of a of k is diverged. Let's just do some questions. I would choose the highest exponents from the top and highest exponent from the bottoms. Choose highest exponent from top and bottoms, so that the series a of k equal with series of 8k to the third minus 2 over 10 the series a of k equal with the series of 8k to the third minus 2 over 10k to the third plus 3. I would compare with this series b of k, which is series of 8k to the third over 10k to the third. So I'm gonna use limit of k to infinity of b of k, which is limit of k to infinity of 8k to the third over 10k to the third, which is equal with limit of k to the infinity of 8 over 10, which is different than 0. So then, based on divergence test, we can conclude this series b of k is divergent. And then, by taking limit of k to infinity of ak over b of k equal with limit of k to infinity of 8k to the third minus 2 over 10k to the third plus 3 times with 10k to the third over 8k to the third. Maybe some of you guys gonna ask like, why don't I just divide it by bk? I just time with this one. So it's just easy explanations. So you divide it by 8k to the third over 10k to the third, which is just equal with limit of k to the infinity of 8k to the third minus 2 over 10k to the third plus 3 times with 10k to the third over 8k to the third. I just flip this one up and this one down, and then time. By that, when I'm taking limit of k to infinity of 8k to the third minus 2 times with 10k to the third over 10k to the third plus 3 times with 8k to the third. This one and this one cancel out. 10 over 8 is just 10 over 8. And then I have limit of k to infinity of 10 times with 8k to the third minus 2 over 8 of 10k to the third plus 3. This one, at this point, I just divide both sides by k to the third, so that I have of k to infinity of 10 times 8 over to the third over k to the third minus with 2, 20 over k to the third over 8 times 10 k to the third over k to the third minus with plus with 30 over k to the third. This one I know it go to 0, this one I go to 0, this one go to 1, this one go to 1, so that this one equals 1. Since 0 smaller than 1, smaller than infinity, and then series of bk is diverged, which we proved here, so that series of ak is diverged. Another question is just series of infinity ke equal 1 to k over k to the third plus 3k squared plus 4 the Haggard exponent in here and here, we have just series of b of k equal with series of 2k over k to the third. And then this kind of series is simple. Series equal the series of 2 over k squared. Using p-series test, then we can conclude series of bk is converge since 2 is bigger than 1. And now we're taking limit of k to infinity of 2k over k to the third plus 2 3k squared plus 4. Using this one, time with 2k, k to the third, cancel this one out. We divide both sides by k to the third, so we have limit of k to infinity of 1 over 1 plus 3 over k plus 4 over k to the third. This one go to 0, this one go to 0, so this one equal 1. So, and then 0 smaller than 1, smaller than infinity, and then series of b of k is diverge. So then series of 2k over k to the third plus k to the 3k squared plus 4 is diverge. And then I just want to ask you guys, for example, the series of 10k squared over k to the third, k plus 1 to the third. Which one is the series of bk? The answer is 10k squared over k to the third. Because you don't really need to differentiate this one out. But if you want to differentiate this one, so it's just 10k squared over k to the third plus with 3k squared plus with 3k plus 1 to the third. So I get exponent from here and here, so we have this point. And then you're gonna use comparison test. Okay. And then for the series D, for example, series of k plus equal 1 of 2k over 3k minus 1. Which series of bk gonna use? For me, the series of bk gonna use Haggard exponents, which is 2k over 3k. And then I know this one for geometric series test. Series of bk equal with series of 2 over 3 of k. The series b of k is converge since epsilon of r is equal with 2 over 3 smaller than 1, then it would be converge. And then using limit of k to infinity of 2k over 3k minus 1 times with 3k over 2k, so this one cancel out, so we just have limit of k to infinity of 3k over 3k minus 1. And then we're using L'Hopital rules, so that we have limit of k to infinity of 3k times with L length of 3 over 3k times with L length of 3, which is 1. Then this one is since 0 smaller than 1 smaller than infinity, and series of bk's is converge, then series of k equal 1 of 2k over 3k minus 1 is converge. Yeah, of course, that like because I skipped some step like these, but in when you're doing the exam and also like when you're doing the work, please write everything's out. K equal 1, K equal 1, K equal 1. Please write everything's out. Don't just like write just like me like this.